What we need to practice today is these formulas. What we don't need to practice today is how to read the directions, verify the identity. Because what does verify the identity mean? Verify the identity? Not conditional equation, identity. Verify. Prove. T-proof, thank you. So verify the identity, T-proof. I don't need to tell you what it means for the directions. Teach you what it means if it says solve for all solutions. Jason, here you go. Okay, solve for all solutions. I don't need to tell you what that means. That means you need to get the trig by itself and look to the unit circle and plus 2 pi n, or Austin, plus pi n, depending, right? I don't need to tell you if it says something like solve for all the possible angles between 0 to 2 pi or negative pi to pi. I don't need to tell you, once again, get the trig by itself, think unit circle, look for only the little angles in that range. I don't need to tell you if it says something like evaluate, it means plug in. What? Yeah, plug in. What do you mean plug in? Well, kiddos, over here, evaluate, plug in. Well, it's already plugged in. Evaluate and solve, right? Okay, what sign? What quadrant? Third. Third sign is negative. 1, what am I doing? Saying it's negative 1/2, but when I said 1, what am I doing? 3, 2, 1, those are cosines all over 2 with little square roots. So when I said 1, I was thinking of pi over 6 angle, because doesn't pi over 6 come before pi over 4? Pi over 3. Yeah, 6 is smaller, 1/4 is bigger, and 1/3 is bigger. Anyway, 1, but it's a negative. How about sine of pi over 3? 1, 2, 3, square root of 3 over 2. And why am I making it a positive? First quadrant. So I need a positive, I need a negative, and there's a minus in between. Dun, 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 dun. What? Well, I guess I could have written it negative 1 minus root 3 over 2. That would be a nicer answer. I totally agree. But how am I supposed to do this subtraction-y one over here? Oh, no big deal. Common denominators, right? We're smart. We're in pre-cal. Common denominators. Isn't 7 pi over 6 minus pi over 3, isn't it the same thing as 7 pi over 6 minus 2 pi over 6? Right? And 7 pi minus 2 pi over 6 is 5 pi over 6, right? And sine of 5 pi over 6 in quadrant, sine is all students. Positive. So it's going to be a positive. What was the point of this problem? Just that we know the unit circle? That's weird. No. The point is that these two are not the same. What? Why would they care about... Oh, what do you think the most common mistake is if I give you something on a quiz or a test? To distribute the sin. It's so natural, and yet so wrong. So, coming back. Distribute the sin. Does it work? No! So how would you solve this if you didn't know? We're just prepping you. You couldn't do this. I mean, this was the homework problem. This is the problem on the board. So we did this to show that they're not equal. How could you make it equal? Sine. If they're together. Oh, with or together. So sine of u, cosine of v. Sine, the signs stay the same. It's a minus. What am I doing right now? Reminding you of the tricks to remember what formulas. How to break this apart legally. That doesn't work. This does. Cosine of u, sine of v. Wait, really? Let's see. Sine of 7 pi over 6, we already said, is negative 1/2. Sine of pi over 1 yet. 1, 2, 3, 3, 2, 1, 1/2. Minus cosine of 7 pi over 6, third quadrant, negative. 1, 2, 3, 3, 2, 1, and then sine over 3. 1, 2, 3. What do we end up with? We end up with negative 1, fourth minus a negative, which is plus. Square root of 9 is 3 fourths. Hey, what's negative 1/4 plus 3 fourths? The only legal way to split up, it's not magic, it's math. The only legal way to split up this guy is using that formula. Are you allowed to distribute sin? So what are the purposes of these formulas? To say how to legally simplify, or wait, simplify. This was simpler. In some ways it is. Can I give you a quick peek as to in some ways it is, in some ways it isn't? What if I was to give you something, just a peek and then we'll do more examples. What if I was to give you something like, section 5.3 directions. Solve for all x within 0 to 2 pi. And I was to give you the equation, quick little example, just to show you the point. Because this looks confusing. Like, this is so much harder than that. I know. But what if I was to give you something like, I don't know, how about cosine of x plus pi over 3 equals Now, some of you might have different ways of doing this. I'm just trying to show you a peek at the idea. So maybe this isn't exactly quite so perfect as it could be. Because some of you are like, just do cosine inverse of both sides. Yes, that's a great idea. Great idea. But what's another way of solving this? Plugging what in? Oh, plugs into the formula. Like, oh, okay. With or together? Ah, nice. With. So cosine, the signs change. Sine. That didn't help anything. Didn't it? Don't you know cosine of pi over 3? 1, 2, 3, 3, 2, 1. How do we solve for sine and cosine? Yeah, question. Anyway, so did we try to use the formula? Oh, hey, have you ever done it on a T-proof? Like you started one way and it wasn't going the right way, and right? Okay. Do we need to learn how to use this guy as to when he's helpful and when he's not? Would have been the best way to solve this equation? Because isn't this already together, the cosine, and I can just do inverse cosine of both sides? And then I can find whenever cosine equals 1 in between, which is going to end up, by the way, being at 0, and set x plus 3 equal to 0, x plus pi over 3 equal to 0 and solve? Maybe I'd also have to do 2 pi, because 0 minus pi over 3. Anyway, some of you are doing the problem with me, some of you aren't. The way that we wanted to have done it is actually here. Well, that's dumb. Then why did you go down to here? Well, what if you were given this? Wouldn't it have been impossible to solve? Unless you went backwards? If you were given this, you wouldn't want to go to the formula. It wouldn't be helpful. We'll hopefully learn some strategies today, like when not to use the formula or when to use the formula. They're going to try and instruct us in the formulas. Sometimes we'll want to go here, but not in this problem. Man, if we were given this, we would want to go here because it makes my life so. Speaking of that, didn't we see one of those yesterday? Where is he? Ah. Who wants to do that? But what does it look like? Ah. But before we get there, hold on, pause. Before we get there, hold on, pause. How on earth could they ask me to find sine of 11 pi over 12 without my calculator? What does the hint say about 11 pi over 12? How on earth could they ask me to solve for sine of 11? 11 pi over 12 is not on the unit circle, but it's the sum of two unit circle values, so actually all the over 12s are able to be solved if you just broke them down and used distributing sin. No! Some of you need to learn that in life, but definitely not in math for right now. Sine with or together? So, sine u not with or together, cosine v. Sine, the signs stay the same. Cosine u, sine v. Do you guys see how I'm plugging into the formulas? The only possible legal way? 1, 2, 2. Oh, because pi over 4 is in the middle of my cheater chart, right? So square root of 2 over 2. Sorry, just kidding. That's the tangent row. 1, 2. 1, 2, 3. 3, 2, 1. 3. Pi over 6 is the beginning. Cosine of 3 pi over 4. 1, 2, 3. 3, 2. Oh, 2. Square root of 2 over 2. 1. And just a few of you remember I said yesterday the cheater chart, if you don't know where the angles are, you're going to be in all sorts of trouble, because when I sing 1, I'm thinking about this column. 1, 2, 3, 3, 2, all over 2. Square. All of that is pi over 6. The next angle, pi over 4. The next angle, pi over 6. The next angle, pi over 2. But my song doesn't really do the axes. 1, 2, 3, 3, 2, 1, all over 2. Square root of 3 over 3, 1 square root of 3. Sine, cosines, tangents for these guys. Just because it saves time. And time is precious on things like tests and finals. Johan, hang in there, bud. I only have one podium. Okay, so equals. Well, square root of 2, square root of 3, square root of 6, right? They're both square roots. We can combine. 2 times 2 is 4. Square root of 2 times 1 is just square root of 2. Well, I mean, I guess they have common denominators, but are these really pretty ones? Nope, we're stuck. Pull a 2 out. No, don't you dare. He's under a square root, little cheaters. But is it right? Yes, it's right. Why don't you memorize it in the unit circle? Oh, they're not that mean. Okay. Can you do the 12s? Technically, take them apart into unit circle values. Now, let's come over to this one. Square root of 3 over 3. Stop. What does this look like? Tangent of, now pause, let me help. Isn't tangent sine over cosine? So think, same, change. What's going to be the operation in between my 5 pi over 6 and pi over 6 if this sine stayed the same and sine changed? Booyah. Now, do you need to memorize tangent of u minus tangent of v all over 1 plus tan u tan v? Sadly, yes. That easily come from the other ones. And if you try to do, oh, it must be sine of u plus v over, sine of u v over cosine of u minus v. Yeah, but it's really nasty to get from there to there. Just memorize, please, please, please. But what does all that mean? No. Ah, yes. Ooh. Tangent of 4 pi over 6, which is the same thing as you would reduce, right? Square root of 3? Nope. Sorry. Square root of 3 over 3? Nope. 1? Nope. Oh. Oh, no one stopped me? Danger. Danger, Will Robinson. Probably no one has seen that movie. Wasn't worth it anyway. Anyway. Square root of 3 over 3, 1 square root of 3. Oh, what quadrant, though? All students, not tangent. Dun, 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 dun. That's cool. Sometimes forward, sometimes backwards, sometimes... Scooby-Doo. Well, they give me a sine of u. They give me a cosine of v. There's a formula for that, right? Can you distribute cosine any more than you can distribute sine? No. Co, with or together. So I need cosine u, cosine v. Ooh, cosine, the signs change. Sine u, sine v. But all they gave me and cosine of v. Now, guys, can I say sine of u is cosine of u? Can I say cosine of v is sine of v? I need you to make a really important. The entire, with a different colored pen, the entire, believe me, I've been doing this long enough. The entire. Do you see that? No more cosine. You know what the cosine is. Negative 3/5. Cosine of v out. Negative 3/5 in. I know it's basic, but oh, so many mistakes happen when they just keep on writing. You just keep on writing the cosines over and over and over. Stop. Cosine v out. Negative 3/5 in. Sine of u out. The sub has to come out of the game for the game to continue, for the new person to come in. Sine of u out. 5/13. Oh, well, awkward. 5/13 in. Well, then how on earth are we supposed to figure out what? Wait. Doesn't this give us two sides of a right triangle? Doesn't that give us two sides of a right triangle? Oh my goodness. There's a right triangle for u and there's a right triangle for v. And guess what happens if we have two sides of any right triangle? Go find the third. U, I know opposite, 5. I know hypotenuse, 13. They told me sine. Oh my goodness, does anyone know the Pythagorean triple for 5 and 13? 12. AKA 169 minus 25 square rooted. Gavin, too much fun. There's the 12. For V, cosine is a negative 3/5. Negative 3 is adjacent, 5 is hypotenuse. Oh my goodness, isn't it a 3, 4, 5? Stop, focus. So, did they tell us cosine of u? No. But they gave us two sides of the u triangle. Psh, you should go find your own cosine u. It's 12/13, by the way. Oh. Did they tell us sine of v? No, but they gave us two sides of the v triangle. You should be able to go find it. It's 4/5, by the way. All the trig are gone because I found all the trig using the triangles. Now, I know it's awkward, but I have all these fractions. All I have to do is a little bit of mental math. That's 36 and that's 65. Any mental mathers? Anybody agree with negative 16 65ths?
Sure.
Dun, 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 dun. Calculator couldn't have done that.
Got it.
Are we learning how to use these formulas? Oh man, I hope so. Now wait. What are the directions? It's either 5, 1, 5, 2, 5, 3. There's an equals, so it's not 5, 1, 5, 3. Is it a T proof? Yeah, it says proof. Starting with what side? Oh my goodness. Right. Tony's like, let's go. No. Wait a minute. Now you guys have options. We could use the sum and difference for both. Or we could remember, wasn't the formula when the other guy was a pi over 2 at the very beginning of section 5.1? I told you to put it in parentheses because you only sometimes see it. It's a cofunction. If it's pi over 2, it's a cofunction property, and we can say, is it 2 plus or minus? Oh, so close. We could have almost used, now careful, you need to know your cofunction properties. You need to know your cofunction properties. Well, it's a plus, not a minus. So what do we have to do? positive-ish, but then he's negative too, so sign's bad. Cofunction. So instead, what are we going to do?
Just do.
Sum and difference for both.
I'll shoot you a second.
Okay. It's going to get a little messy because his formula is going to take up a line, his formula is going to take up a line. So I'm going to do a big old like, something like that. His formula, co, with or together. Am I trying to get you to memorize these formulas just from class time today? Yes. Co. Ooh, cosine. The signs change. Sine. Plus, because there's a big old plus. Sine, with or together. Sine, cosine. Sine, the sine. Same. Flip it. No, not flip it. Cosine of u. Shouldn't be following me. You know better than that. Just kidding. Wait a minute. There's so much stuff. I don't know what to... Hold on. Don't you know that? And that? And that? Yeah, you do. Johan, last try, or else I'll just, I don't know, something. Stool on top of a desk. Okay. Cosine of pi. Another 1, 2, 3, 3, 2, 1. Pi is, it's so much easier to think about the axes, right?
Yeah.
Isn't cosine x? Isn't? That's going to be a negative 1. So I'm going to end up with negative cosine theta from that piece. Sine of pi is 0. What's anything times 0? Nice. Plus sine of pi over 2. Isn't sine the y? Which is going to be a 1. Oh, cosine. And then what's cosine over 2? No. X. 0. Dun, 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 dun. Well, that wasn't bad. Is the unit circle important at all? Yes. Okay, what are the directions pointing us to? If it says 0 to 2 pi, find all. Section 5.3. 5.2, 5.3 is just showing up in 5.4. Good. Look at this. It's all review. We're reviewing every new section we do. Yes, we're just adding new formulas. You're welcome. What can I say? Okay, sorry. So, this would be so easy if I could just distribute sin. Spread kindness. Okay, so what do? Guys, what formulas are you using all of homework long? It's a sum and sine. With or together?
Yeah.
No, that's co. So you tell me the formula. I've been working hard all class. Go. Sine u. Good.
Cosine b plus
Stay the same.
cosine u sine
See, fall in. Exactly. For him. This is negative 1, and the y is times anything? Forget him. We have negative sine of x. Negative sine of x. Please don't mess up now. What's negative 1 minus 1? Thank you. P.S. If it went away, 0 plus 0 doesn't make sense, so hopefully we would figure out thing went off. You guys know what we're doing. We're getting sine. So. 1. Got it. But wait a minute. Why am I going to answer pi over 6 and 5 pi over 6? Sine is positive not only here, but also all students. Right? All students. All are positive? Got him, coach. Sine is positive? Got him. Dun, 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 dun. 5-1, 5-2, 5-3. Coming. Up and then. Oh. So question. What would you say is the formula for cosine of, one person raising a hand, major brownie points? Wish I had candy, but I don't. Do I? I don't. Maybe get candy second semester, make it fun. Didn't get the half price Halloween candy because it was for troops. Anyway, coming back. Lo siento. What would be the formula for cosine of u plus v? Tony. Did you guys hear the with or together and the sign change?
Yes.
Booyah. Who has a formula for sine of u plus v?
Sine u times cosine u plus cosine u times sine v.
Did you guys hear the not with or together and the signs stay the same? Ready? What's tangent of u plus v? Did you hear that sign stay the same and then sign change with a nice little, and she had, okay. Homework questions. 5-5. Last section. 5-5. Last section. 5-5. Last section. I've looked at the calendar. I have said that the quest is on Monday. I'm partially right. And I'm partially wrong. Part of the test is on Monday. Part of the test is on Monday. Which part? The formula part. Where I give you one side with an equals and a blank and you give me the other. Of quotients, reciprocals, and Pythagoreans, and maybe a couple even odd, maybe a couple cofunction, and some indifferent, and double angle. What's the second half of class on Monday? Going over any questions you have on the review that's due on Monday? 5-5? We'll see. I guess technically in order. Questions on 5-5. And questions on the review that you should start over the weekend. Lo siento. So what's on Tuesday? The problem part. Hopefully only taking half of class. Then we can talk about the final, and then Wednesday, Thursday, Friday, just review, and work on the bonus final review. Worth up to 5% back on your final exam itself. Anyway. Good things coming in your future. If that was a fortune cookie fortune, there you go. What do you see? Do you guys see how he has 3? Guess what? There's a formula, a blank one, on the quiz that hasn't been copied yet. With cosine of 2u and an equals and an equals and an equals. Oh. Welcome. But guess what? He's important in calc. A, B, and B, C. Oh. I guess we better learn him now. Then we'll review him later. He's important in calc A, B, and B, C. Oh, I guess we better learn him now. He's not so much. Do you want to go throw him in parentheses? He's important for the homework, not so much for the quiz. You're welcome. Or I should say the test part 1. I wish there was some sort of way of figuring out the cosine 2u formulas and how they all work together. Hey, can't we transform things? And aren't these squareds? Guess who the most important person is, even though there are 3 blanks on the formula quest, part 1, whatever. Can't I look at what you want? Can't I get rid of the sine squared to make it 1 minus cosine squared? Minus and minus is a plus, and the cosine squared plus a cosine squared is a 2 cosine squared minus 1. Oh, it comes. Can't I keep the sine squared? Minus sine squared is 1 minus 2. Oh, both of those come. Them all. How on earth They're going to ask us to use new formulas. Oh my goodness, 5.1, 5.2, 5.3, just with new formulas. So guys, section 5.3, yeah? Subtract the sine 2x and divide by sin. No, that's a bad idea. Ooh, maybe use a formula because we have one? Isn't that 2 sine x cosine x? Why on earth was that helpful? Should I be afraid of factors? Not when they're equal to? If they're equal to something else, I should be very scared. But do you see anything in common? I do, right? Do these formulas make the impossible possible? Why, yes, indeed, they do. So all those problems you saw in section 5, the nice little basic. Now, some were difficult. I'm not saying they weren't, but they weren't using these further formulas. When does subtract 1, sine equal -1? We'll talk about it. When does cosine equal 0? We'll talk about it. Wait, those are on the axes, right? It's not 1, 2, 3, or 3, 2, 1. Oh, well, sine is the y. Y is -1 at, oh, here he is. And isn't that going to be 3 pi over, you're right location, wrong angle. I need to go negative to get there. 3 pi over 2 is too big. So I could say negative pi over 2. And then when is the x 0? Pi over 2 and, oh, well, we already have the other one. Do you guys see why I spent so much time on 5.1, 5.2, 5.3? Those are the directions for the rest of chapter 5. So what are you seeing in 5.4 and 5.5? New formulas. Do you have to memorize them all? Well, so far, basically, yes. The even odd, just 1 or 2. The cofunction, just 1 or 2. Double angle, just the main ones. Now here's a little bit of a struggle. Ideally, we'd start reviewing tomorrow, and we might. But are those the only formulas? Like, it kind of seems like we're sort of done in a way. Maybe some homework helps. Okay. Still looks like double angles. Okay.
Okay.
Oh. Okay. All right. No big. Oh. Okay. All right. We're good. Now, hold on. Were all of those highlighted? No. Okay. So some of these, it's literally like just have your book open to the formulas and see if you can use them. Yes. Yes, for homework 5.5, because some of you are going to maybe try 5.4 and 5.5. But do you guys see how the directions are still 5.1, 5.2, 5.3? Yes. Do you have to memorize all of them for Monday? No. But all the ones with yellow boxes, yes. Should you maybe start making formula cards tonight? Bye. See you later. Which ones are on the quiz? The highlighted ones.
Yes.
Bye, guys. Can you guys memorize? Come on, you have to memorize in all classes at some point. Memorize, memorize, memorize.